Okay students, welcome back to my YouTube channel. I have already uploaded two videos for the freshers who have just come to advanced level, right? So in the very first video, I explained about combined mathematics and the streams that are available in advanced level, and if you have decided to mathematics, how you should study and what you should study. And I uploaded another video also. Actually, I was intending to record the full video for a long time, but unfortunately due to lack of storage on my mobile phone, the video stopped in between, and then I went live on YouTube. But still that video is processing, but I will provide the link for that live video in the description. You can first go to that video and watch, where I explain the structure of the combined mathematics paper, and I started introduction to algebra, right? So there we studied some basic concept about indices, and uh, finally I told you in another video, I'm referring to the video that currently I'm recording, right? So in this video what we will be looking at is expansion of algebraic expressions, right? So let me first write down the headline: expansion of algebraic expressions, right? So this is our topic today. So this is also what you have learned in your O levels and grade 10, right? So this is basic, these are basic things, but to complete our journey in physical science stream, we will need these things, not only in combined mathematics, even if you in physics also you might need these things, right? Okay, now the first expansion. So expansion means we are going to extend an algebraic equation. So the first thing is you are familiar with. So a plus b holding square. So we have to expand, or we have to extend this, right? So this is, you know, right? So the expansion, you have memorized it. But you see, this is how we obtain the expansion of such expressions, right? So a plus b holding squared means this seems like x squared, right? So x squared means x times x into x, right? So instead of x, I have an expression a plus b then square, which means a plus b is multiplied by another a plus b, right? So I don't want to write this multiplication symbol, right? So now what I have to do is, now here in this expression we have two terms, and here also we have two terms. Now this a should be multiplied by this a and this b, then this b should be multiplied by this a and this b. So we will get a times a squared plus ab, right? So a into b, ab plus ba plus b squared. Now you see 2 into 3 is equal to 3 into 2, right? Okay, now likewise we can write, so a squared plus ab. Now this ba can be written as again ab plus b squared. Now we have a squared plus now one ab, another ab. So we have two ab's plus b squared. So the expansion of a plus b holding square is equal to this. So how you can remember is, now you have exponent 2, right? So you put the exponent to the first term and you write here, then 2 into, so you 2 into a into b, 2 into a into b. In this case you have to consider the the sign also. Now then again at last you have to put b into square. So this is the first thing that we have to study. Now what you have to do is, we have to expand a minus b holding square. Okay, so basically you know the expansion of this, right? So only difference is here you will get minus, but how can we write this? Okay, so here this is also, we can obtain this expansion of this expression in different ways. Even if we can obtain this in two ways, but I will explain one way, right? So like classically, like we have done for the first one, you can just write this as a minus b into a minus b, and you can do the procedure again to obtain the expansion of this. Otherwise, I can write in this way also. You just look at here. A plus minus B holding square. Okay. So you see A. So instead of I have just I have written this minus as plus into minus, right? So A plus into minus minus B. So I get this. Now wherever I have B, so in this equation, wherever I have B, I will just going to, otherwise I can write in this way. Okay, wait. So from the first result that we have obtained, I will just apply, so substitute B is equal to minus B in this first equation. Now what will I get? A plus minus B holding square is equal to A square plus 2 into A into B, but we replace this B by minus B plus minus B holding square. Now you see A minus B plus into minus minus B holding square is equal to here A square. Here this minus and this plus gives you minus 2AB. Now you see 2 squared is equal to 4 and minus 2 squared is equal to minus 2 into minus 2, which is equal to this minus and this minus gives you plus 4, right? So plus B square. So this is the expansion of A minus B holding square, right? Okay. Now we will look at A plus B power raised to the power 3, right? Power 3. Right? So we have already discussed that A minus B holding square is equal to how A square minus 2AB plus B square. How is it coming? A square, then you see 2 into this A into this minus B, right? This minus B. So 2A minus B minus 2AB plus minus B holding square. That will give you B square. Okay. Now third one, A plus B holding raised to the power 3. Now how can I write this? Now can I write in this way? A plus B holding square into A plus B. We have already studied the laws of indices also. You see the base is the same. In that case we have to, when two indices with same base are multiplied, we have to just add the indices, right? So here A plus B power 2 plus 3, that will give you 3. Now we have already found out the expansion of this one, that is equal to what? A square plus 2AB plus B square into A plus B. Now in this expression we have 3 terms, 1, 2, 3 terms, and in this expression we have 2 terms. Now what we have to do is we have to multiply this by, okay, now if I write this in this way, right? So 2 times 3 is equal to 3 times 2. We can interchange the position in multiplication and in addition, right? In addition and in multiplication only we can interchange the positions of the numbers that are multiplied or added. Now this can be written as A plus B holding square, A plus B into, right? Okay, now I just write this A plus B here, A plus B here, this A plus B is written here, and this, instead of this I write A square plus 2AB plus B square, right? Now I multiply this A, the first term of the first expression, by all the terms in the second expression. So it will give you A times A square, so A cube plus 2A into 2AB. So 2 into, we have A square into B. So A into 2AB. So 2A square B plus, then again AB square. AB square plus, again this B, the second term of the first expression should be multiplied by all the terms in the second expression. So it will give you BA squared, BA squared. But better to write in the alphabetic order. So I can write BA squared, but A comes first in the alphabet. So I can write A squared B, right? A squared B, then B into 2AB, right? So this will be equal to 2AB squared plus 2AB squared plus B into B squared, that will give you B cube. So this is the expansion of this expression, right? Now we have to identify the similar terms here. So here A cube, is there any other A cube? No. Then 2A squared B, here also A squared B. So these two are similar terms, right? So these two are similar terms. Now what I will write is A cube plus 1A squared B, another A squared, 2A squared B plus another A squared B. That will give you 3A squared B plus, so you see AB squared here, another AB squared here. So 3AB squared plus B cube. Now this is how you have to remember, right? A plus B cube. Now for example, if it is A plus B whole thing square, so we just put the exponent of the whole expression to the first and second terms, right? Likewise here also we have to put the exponent of this expression to the first and second terms. So A squared B squared. Then you see 3 should be written. 3 should be written, right? Like we wrote 2 here. 3 should be written. Then you reduce one exponent of the first term, right? A squared. Then you see you have to write the second one, right? So this is basically like this: A cube B naught, right? So I don't know if you will confuse if I told this, right? This is equal to 1. You see, okay, now if I write in this way, you will understand better. 3A squared B plus 3A squared B squared, 3AB squared plus A naught B cube, right? So you see in this expression the exponent, you just look at the exponents of this A here. So from 3 to 1 0, so 3 to 1 0, likewise it's reducing, right? So the exponent of the first term is decreasing while the exponent of the second term increases. So you see 0 1 2 3, the exponent of the second term in the expression is increasing, right? So this is basically 1 and this is also basically 1. So this is the expansion of this expression. So how you have to remember is, you just put the exponent to the first and second term and write in the two terminals, A cube plus B cube. Then you have to write 3, right? 3. Then you reduce 1 in the exponent of the first term. You reduce 1 and you write the next term, the second term with exponent 1. So A squared B plus 3AB squared. Here again we have reduced 1, but here from 1 you have increased another second term, right? So 3A squared B. You can just see a pattern here. You can see a pattern here. Here the power of A is 3. Here the power of A is 2. Here the power of A is 1. Here the power of A is 0. Here the power of B is 0. Here the power of B is 1. Here the power of B is 2. Here the power of B is 3. So the power of the first term is increasing while the power of the second term in the expression is increasing. Okay. So this is the expansion. Now see, A minus B whole the cube. So the expansion of this is very simple. You just remember this one, right? So A cube, you put minus 3A squared B plus 3A squared B, 3AB squared minus B cube. So this is the expansion, right? So alternatively you have to place minus. Okay, alternatively. So here you see plus. Then in the second term of the expansion you have minus, and in the third term of the expansion you have plus. So alternatively, one after one you have minus, one after one you have minus. So how you can, so you can just remember this expression. Now I will explain how to obtain the expansion of this expression. Right, like we did for the first expansion, I mean the a minus b holding square, I will tell, right? So you should remember this one, a plus b holding cube. So I will tell, heck, how can we write this? A cube, right? Then 3 should be written, then a square, we are reducing 1, then b will come, b will come to the picture, then plus 3ab square. Now another b has come and 1a has reduced, plus b cube. So this is the expansion. Now if I want to make this a minus b, I just want to substitute b is equal to minus b. Now substitute b is equal to minus b. So what will I get? A minus b holding cube is equal to a cube plus 3a square minus b. So here we have b, but I have to put minus b, plus 3a minus b holding square plus minus b holding cube. Okay, now you just see this. Now, okay, simply look at this, right? So minus 3 power any number n, right? Okay, any number. So let me take 2. So this will be equal to minus 3 into minus 3, right? So this will be equal to plus 9. So I will take another example, minus 3 power 3. Now this is equal to minus 3 into minus 3 into minus 3, right? So this is equal to minus into minus 3, 9, and minus 3, that is minus 27. Now if we have a negative number and if the exponent is odd, then you will get negative value. So you see, before 27 we have negative, but if it is positive, even if we have a negative number but the exponent is positive, so the total value will be positive. So you should remember this. Now this will be equal to a cube, so this minus and this plus will make this minus 3a square b, right? You see, this minus b holding square, so minus b holding square is equal to minus b into minus b, that will be equal to minus into minus plus b square, right? B square. And so this will be equal to plus 3a b square. Then you see, here minus b power 3, this will be equal to minus 3 into, minus b into minus b into minus b. Minus b is multiplied 3 times. So here minus into minus plus, then with this minus it will minus b cube. So this is equal to minus b cube. So this is the expansion of a minus b holding cube. Okay, right. Now we will look at the expansion of a plus b plus c holding cube, right? I hope you have understood how to write the expansion of this expression. So whether, now okay, now let's try this one, minus a plus b holding cube. So can you try to find out the answer for this expansion? So you see, minus a holding cube, right? Minus a holding cube, then plus 3 into minus a square, then b, plus 3 into minus a b square, right? B square. With time you will be familiar with these things, and without writing these things you will quickly write the answers, right, for these kind of expansions. Plus again b power cube. Now you see minus a power 3. So minus a is multiplied by 3 times. So minus into minus plus, then plus into minus will give you minus a cube. Minus a cube. Right? Minus a cube. Now you see this is positive a square, then plus 3a square b. Then you see here minus 3ab square plus b cube. Right? Okay, this is the expansion. And if it is like this, how will it be? Minus a minus b holding cube. So here minus a holding cube, my plus 3 into minus a in minus a square into minus b plus 3 into, I don't know if you can see the one. Yeah, minus a into minus b square plus b minus b holding cube. So this will be equal to what I am writing here, right? So minus a cube, right? So this plus a square minus b. So minus 3a square